Welcome to the deep dive. Today we're plunging into a data challenge that's been really tough to crack for, well, ages, really.
Right.
But it's now facing a massive transformation thanks to AI.
Hmm.
We're talking about unlocking knowledge from unstructured data, specifically documents.
Exactly. And we've got some great source material today from an IBM technology session to guide us.
Okay.
So our mission really is to zero in on why something so familiar, like a document, has been such a persistent problem for tech.
Yeah.
Explore the AI breakthrough that's changing things, and then look at how these AI agents are being built to actually tackle this, turn those piles of information into usable knowledge for you.
Okay, let's unpack this because documents, I mean, we use them constantly, right? Emails, reports, contracts.
All the time.
They feel fundamental, but you're saying from a data perspective, they're actually a problem.
Oh, a huge problem. I mean, think about it. Written language is how we've recorded important stuff forever, right?
Yeah.
Cave paintings, scrolls, print, now
It's
PDFs.
how we share knowledge.
It's the bedrock. But from an engineering point of view, that flexible human language makes documents inherently unstructured data.
Unstructured data. Okay, so the opposite of like a neat database or a spreadsheet.
Exactly. Where everything's in tidy rows and columns. We want data we can use for decisions, and ideally that means structured data.
Right.
So with documents, the goal's always been, well, either force that unstructured mess into a structure machines can use, or, make it easier for humans to work with the raw stuff.
And it's not just the words themselves, right? The source mentioned the complexity within a document.
Oh, yeah, absolutely. They're way more complex than they look. I mean, length varies wildly. Short email to a massive 600-page contract.
Wow.
And inside, you've got all sorts of data types jumbled together, words, punctuation, sure, but also numbers, dates, weird symbols, and then tables.
Tables. They seem structured, but maybe not.
Kind of. You might get a simple little grid, sure. But you also get really complex ones, tables that break across pages, tables with like 10,000 rows sometimes.
Okay, that sounds messy.
It is. That variation, the mix of data, the visual layout, it makes it super hard for, traditional software to really understand automatically.
So before this new AI wave, how did we even try to manage this document data?
Well, the main tool for a long time was OCR, optical character recognition.
OCR, right. I've heard of that.
Yeah, it uses computer vision. Basically, it teaches a computer to see the document image, to recognize characters, words, sometimes basic tables, and just turn the image into digital text.
Okay, so getting the text out, that feels like a good first step. Does that solve it?
It's necessary, definitely, but it only gets you so far. OCR gives you the words, yeah, but it struggles with those complexities like table splitting across pages or understanding formatting.
Ah.
And the big thing is it gives you zero semantic understanding. It doesn't know what the words mean or how sentences relate or the context. You just end up with a big block of text.
Right, so you've digitized the ink, but not the actual meaning. Which I guess leads to another big challenge the source brought up. Documents don't usually live alone.
That's so key. Often the real value isn't in one document, but how it connects to others. They exist in relationships, forming what the source calls document hierarchies.
Hierarchies, okay.
Yeah, it's about how a whole population of documents fits together logically.
And the source mentioned two types, vertical and horizontal.
That's right. Vertical hierarchies are like documents stacking up to show a whole process or transaction. Think finance or legal stuff.
Okay, like what?
Well, you might have a master service agreement, right?
Yeah.
Then under that, a specific statement of work, maybe some amendments to that SOW, then a purchase order, then an invoice.
Ah,
To get the full picture, you need to see how they all link up vertically.
like building blocks, one depends on the next. Okay, what about horizontal then?
Horizontal is a bit different. It's less about that linear chain, more about different kinds of documents that relate to the same thing as it evolves or, as transactions happen.
Okay. Example.
The source had a good R&D one.
Mm.
You start with a research paper, R1. Then another paper, R2, comes out and cites R1. Then R3 cites R1 and R2. That's kind of the vertical citation flow.
Right.
But horizontally, that core idea might then lead to a U.S. patent filing and later product documentation. You're tracking the idea's evolution across different types of documents.
Ah, okay, so connecting different views of the same project or idea.
Exactly. Or like supply chain. You've got a bill of lading, a certificate of insurance, the shipping receipt, maybe later a claim if something went wrong.
Right.
That claim relates horizontally back to the shipper, the recipient, the insurance cert. You need to link all those different pieces to understand the whole shipment story.
Okay, so we've got documents that are complex inside and they relate complexly outside, vertically and horizontally. And old tools like OCR just give us text, none of that understanding. So this is where the game changes.
This is exactly where large language models, LLMs, come in. We're talking foundation models like GPT systems. This is the fundamental tech breakthrough that makes tackling document data at scale finally look, well, possible. Right. Everyone's heard of GPT. But why can it handle language so differently than OCR or older NLP? What's the magic?
Well, it really comes down to the transformer architecture they use. Language, like English, it's huge, but it's mostly finite, right? About 170,000 active words, alphabet, numbers.
Finite but massive.
Exactly. What transformers do is sort of map this space mathematically. Older methods might put words on a simple line where distance equals similarity.
Okay.
Transformers build this incredibly complex, high-dimensional space. Think of it like a multi-dimensional map of language
A
itself.
map of language. Interesting.
Yeah, and they use billions, sometimes trillions, of parameters, values, learned from seeing tons and tons of text to figure out all the relationships between words, phrases, concepts within that complex map.
So it's not just about words being near each other. No, it's much deeper. It lets them
hmm
understand context, nuance, synonyms, how ideas connect across sentences, paragraphs, even whole documents. It's like the difference between just looking up a word that's OCR and actually understanding a complex paragraph in context that's the LLM.
That ability to see the deep structure and meaning, that's the key.
That's the core breakthrough, yes.
Mm.
It lets the model really read and comprehend the content and the relationships inside the text in a way only humans could before.
And all those technical terms the source mentioned, embedding, attention, softmax.
They're all just parts of the engine, basically. Embedding turns words into points on that map. Transformers build the map. Attention helps focus on the important parts. Softmax predicts what comes next. It all works together to parameterize and understand language incredibly deeply.
Okay, so the LLM gives us this amazing understanding inside the document. How do we actually use this in a processing pipeline? Back to that 1,000-word doc where we want 20 key points. You said it's not just shrinking it down.
Right? That's the counterintuitive bit. You'd think, okay, just read it and pull out the points, reduction. But no, the modern way, with LLMs, it's actually a huge expansion first.
Wait, expansion? How does pulling out less information involve making more data first?
Think about the steps. You start with a document file. One data point, sort of.
Okay.
If it's an image, you run OCR. Boom. Pixels turn it into character data. Maybe millions of points right there.
Mm-hmm.
Then NLP adds more layers. Grammar, entities, sentence structure. More data.
Right.
Then the LLM processes all of that, creating its incredibly rich, high-dimensional understanding. You've maybe gone from one document to potentially billions of intermediate data points representing a text structure, meaning relationships.
Wow. So you blow it up first to understand it deeply.
Exactly. It's this expansion phase, OCR, then NLP, then LLM processing.
Yeah.
It creates this massive, complex, but deeply understood digital version of the document. Then, only then, do you start the contraction.
Ah.
You use tools, often using the LLM itself again, to query that huge intermediate representation and pull out just those 20 or 50 key data points you actually wanted, structured the way you need them. Expand to understand, then contract to the target format.
That makes sense now. Expand, then contract. Okay, so how do we manage this whole complex pipeline, especially with these powerful, flexible LLMs? Sounds like it needs something more than a simple script.
And that's where the solution layer comes in. AI agents and agentic workflows. Instead of one giant program, you build specialized AI agents, like little digital experts.
A team of specialists.
Precisely. And the source gives some great examples of the kinds of agents you might use.
Okay.
An inspection agent does the basic file, check size, type, checksums, just validating the input file.
Got it.
An OCR agent takes image docs, outputs text and tables. Could be old school OCR or a newer multimodal LLM. A vectorized agent works with the LLM, turns text into those mathematical vector things, chunks the doc up maybe.
Oh, the math map part.
A splitter agent, really useful, learns to chop up files that have multiple documents scanned together.
Oh, yeah, that happens all the time.
Then the extraction agent. This is key for the contraction part. It uses automated prompts, guided by what you want to extract, to find and pull out those specific dates, names, amounts, whatever.
Target data points.
And finally, a matching agent. This one looks across multiple processed documents, using metadata and extracted info to figure out those horizontal and vertical hierarchies automatically. It connects the dots between documents.
That sounds like a really powerful set of tools. How is a workflow built with these agents different from, say, a traditional process?
Well, traditional workflows are usually very deterministic, right?
Hmm.
Linear. Step 1 finishes, output goes to step 2. It's output to step 3,
Yeah.
like an assembly line.
Fixed and predictable.
Yeah. Agentic workflows are designed to be way more autonomous, more dynamic. Agents can be triggered by events, like a new file arriving.
Hmm.
They don't just wait linearly. They might look at what other agents have done and decide, okay, now it's my turn, based on rules or even learned behavior.
So they're not always following the exact same path.
Exactly. That means they're often non-deterministic. The precise sequence might vary slightly each time, depending on the data.
Non-deterministic.
Right.
That sounds potentially chaotic.
Well, it can seem that way,
Yeah.
but it gives them incredible flexibility and scalability.
Yeah.
They can adapt to unexpected things in the data. It allows for emergent behavior, finding connections maybe you didn't even explicitly program the workflow to find. It opens up new possibilities because it's not rigidly fixed.
Okay, let me try and wrap this up. We've had this long-standing problem with documents unstructured, complex internally, connected externally. Old tools like OCR barely help, then boom, LLMs arrive, giving us this powerful way to actually understand the meaning and relationships in the language via that complex math mapping.
Right.
And now AI agents are being used to build these dynamic workflows, doing that expansion then contraction process to finally automatically pull useful knowledge out of huge piles of documents.
That's the essence of it, yeah. And the potential value for you is just immense. Imagine querying thousands of contracts instantly, analyzing millions of invoices for trends, synthesizing research papers. It makes information accessible for decisions in a way that was just impossible before.
It really feels like moving from knowledge being locked away in document prisons, needing humans to manually free it, to a future where these AI agents can kind of navigate that landscape for us.
Good way to put it.
But here's a final thought then. If these agentic workflows are dynamic, autonomous, non-deterministic, what does that really mean for controlling the results, for ensuring accuracy? And what's the role for, human insight and oversight in this increasingly complex AI-driven data world? Something to chew on next time you're faced with a stack of documents.